Good afternoon, and welcome back to KAUST Live. We're coming to you from the Winter Enrichment Program. This year's theme is Human-Machine Future. We're talking about the ways that, the ever-changing ways that technology is playing a role in our daily lives. Today to talk to us about that is Alexandru Budisteanu. Alexandru, thank you for joining us.
Thank you very much for inviting me over here to talk.
For sure. You're perhaps best known for designing a self-driving car on the cheap, and even developing a way for the blind to see with their tongue. So we'll get into a little bit of that in a minute, but I want to know, what are you up to right now? What's your latest thing?
Yeah, so at the moment my company is building a few products. One is VisionBot, is like an affordable pick-and-place machine, like robot that assemble electronics. And it is mostly intended to be affordable for makers, SMEs that are looking to manufacture electronics. But in the same time, we're also trying to switch a little bit from hardware, because in Romania I actually built a small manufacturing facility to manufacture those robots, and I found that it's very hard to scale hardware business. So at the moment we are building a cryptocurrency. It's called WebDollar, and we are planning to launch it, the official mainnet, in just 1 month or something like that. And you know, I'm just trying to use my mind in order to build great stuff for the humans.
Yeah, of course. So you've been fairly successful. I mean, what do you think are the keys to your success, whether it's been startups or school or anything else?
I don't consider myself successful. I'm just trying to, to work as much as I can. Also, I'm a computer geek, so I really love to stay in front of the computer working most of the time. Before coming over here, I was just like working in the hotel for my project, for the cryptocurrency. And yeah, the keys in order to succeed are just like hardworking. Just need to work hard in order to be able to see your project from an idea to see it to a prototype, and from a prototype to see it in the hands of the users. And in order to achieve that, it's just like hardworking. It's just like trying to as much as you can to dedicate to build that stuff from the scratch, and after you can see that it's working and it is validating your concept, it is validating your assumptions at the beginning, then you are trying to scale that manufacturing or something like that, the software, to be able to use by as many users as you can. And yeah, the thing is that all the time I was also trying to think too big, and in order to be able to achieve those very big dreams, it is a lot of work to be done behind, and yeah, we will see what's going to happen next.
Well, what do you think is motivating you through all of these different steps, whether they are or aren't a success? You can be the judge, but I mean, what do you think keeps pushing you forward to generate new ideas?
Yeah, so I'm a computer geek, so because I'm really connected to the computers, for me it's super easy to change from one product to another one or something like that, especially if I'm refactoring most of the code. It is not necessary to scratch from the beginning. And I'm just trying to see where I can go, and also I'm trying to see what people actually need. Because, for example, I've also been working to a social network like a Reddit kind of platform called SkyHub, and I saw that it was not very sticky, and that's why we forked the project to a cryptocurrency mostly in order to make a web application, a web cryptocurrency called WebDollar that can be used by anybody with a browser, with a mobile phone, and you can see your transactions, you can see your balance in your computer on your mobile phone. And we are trying to develop technology that is very disruptive, but the problem is that when it is too disruptive, it is very hard to be done. And yeah, we are trying, and I know that maybe the success will not come in 1 year, maybe in 2 years, but in 5 years definitely will gonna come if I'm gonna work hard as I was working before. Also, I truly believe in the Malcolm Gladwell idea, the 10,000 hours of experience in order to become a professional. So if you're a professional, then you can do a lot of great stuff.
Right. Let's get into that WebDollar part of your experience. So it would seem from the outside, from a layman's perspective, that obviously Bitcoin has sort of taken over the main space in that field. How are you going to disrupt that? What is it that's different that you're doing?
So the thing is that Bitcoin it is a prototype, and it was designed as a prototype in 2008, and almost nobody actually introduced any kind of new concepts and simplified the Bitcoin system itself. So everybody's talking about Bitcoin, but Bitcoin is a software, terminal software. that you have to install on the machine, and it is designed for developers, for computer geeks, and not for end users for stream media or something like that. And so we are trying to simplify the entire system to be used on any device without installing anything. Just use your browser, your Safari, your Chrome, and you have the WebDollar wallet. You can mine in the browser, you can check transactions, you can send transactions, and it will be super easy to be integrated in web application because it's native to the browser. So it's super easy for e-commerce websites. In just like 5 minutes, they can integrate the WebDollar payment in order to send and check transactions if they were done by users for paying for that product. So we want to simplify the entire process in order to be used in the browser, in the websites, because Bitcoin, it's an internet protocol, but it was not designed for the web. And we're designing for the web. And it's very disruptive. The question is if we are able to succeed or not.
Right. And I think part of what the Bitcoin phenomenon is built on is blockchain. So talk a little bit about that. Are you building on top of that?
Yeah.
Are you integrating with that? Or?
We are using a light version of the blockchain because the Bitcoin blockchain is 140 gigas of data, and you cannot download that on your mobile phone. And we are using two new concepts, especially mini blockchain that is introducing a new mathematical model for balances and not transactions. And beside of this, we also use a new concept, proof of work on the blockchain, which is making your phone to be connected to the blockchain in 10 seconds or something like that. And it is a light version of the network. And it can be used by mobile phones. The only question will be the number of the transactions per second, but this can be achieved, increasing the number of transactions per second can be achieved in the near future when this internet will become faster, because centralized systems, they can have a lot of transactions per second, but the centralized systems, they need all the transactions must be verified by all of the nodes in the system. So that's one of the biggest disadvantage of decentralized systems. But as the internet and the technology evolves, automatically also the number of transactions will be increased.
So I mean, that seems like a tremendously large undertaking. What gives you the energy and the enthusiasm to take that on? Yeah,
actually we didn't want to do any kind of ICOs or something like that. We are just trying to build a technology to see if we can achieve that. We wrote about 95% of the protocol. We even launched just like 1 week ago the first testnet of the system to check the security flows and so on, and we had about 400 miners already who tried to mine the WebDollar on the testnet, and and we are trying to see if we can build that stuff, and after that we saw that the markets really want something like that.
Talk a little bit about mining for those of us that don't understand. How does that work exactly?
So it's super simple. You have a decentralized system, and automatically all the transactions like mathematical formulas. The only thing that two computers can discuss and agree with each other. So the proof of work concept from blockchain is quite a decentralized random generator that all of the computers from the network, all of the nodes, they agree on which person actually generated the first lucky random.
Okay.
And it's auto-adjusting itself. There is a proof of stake, which is different than proof of work. So there is no longer that kind of mining. So there are like technology solutions and math solutions to be done in decentralized networks.
Right. And so again, for the lay people, how does that actually turn into money? Like, why is that something that you can trade with?
So the main idea is that the security increases as the security increases with the nodes. If you have more nodes, then the security increases. If you have more computers that are checking the balances and checking the transactions, then the security of the system will increases, because an attacker will need to have almost the same kind of network, not only 1 second or 1 week. He also needs quite a long time in order to hack the system, to hack a blockchain system. So automatically the security of the blockchain increases with how many nodes you have in the network. And if you want to keep those nodes for checking the transactions and checking complex formulas, then you have to reward the users.
Right.
And the way Satoshi proposed was every block will generate some coins for the lucky person who was able to get that very complex formula to be solved.
Interesting.
And that's the way it works. The proof of work, there is also proof of stake, but it's a little bit strange. Yeah, that's based on, it's a very complex formula that is adjusting every 10 minutes in Bitcoin in hours, 15 seconds. And just one computer in 10 minutes, 15 seconds, and us will be able to solve that formula. And an attacker will need almost half of the size of the network to be able to be competitive with our network. But also it needs long time in order to crack the system.
I see. And that sounds impressive to me. You're from a place that is quite notorious for hacking, actually.
Yeah.
Tell us a little bit about that, and then explain why people should want to buy into a currency system from someone from a place that's notorious for its hacking.
Yeah, so yeah, I'm from Râmnicu Vâlcea, and I was born over there. I was raised in Râmnicu Vâlcea. Also, my headquarters is in Râmnicu Vâlcea. We have 2 offices right now.
Known as Hackerville.
Yeah, the Râmnicu Vâlcea is called also as Hackerville because there were in the past, there were so many cyber criminals or something like that, and but they were doing with banks because banks are centralized and banks can be quite fraudulent or something like that. The centralized system cannot be hacked in one way or something like that. Either you crack the entire system or not. So this is the main advantage of the centralized systems, because you cannot just hack 1% and then you cannot do that, something like that. Either you hack the entire system but it doesn't have any value anymore, or you cannot. And the proof was you couldn't, and nobody could be able to crack a proof of work from Bitcoin.
Right.
And yeah, and what's interesting in Eastern Europe, there are a lot of software developers and a lot of programmers. And also, when I was raised, I have computer from age of 3. That's like 1995 or something like that. And I was playing a lot of games, and after that I started coding. I'm building like the Vision Bot pick-and-place machines in Râmnicu Vâlcea. We have a small manufacturing facility over there where we manufacture. And about the Hackerville, actually, I don't know why, but in my 7th class grade, when I was like 13, I actually built an antivirus. A small antivirus. It was called Romanian Penicillin. It was more like a challenge for myself. If I can build like a small antivirus that can detect, a couple of viruses or something like that, and it was interesting. And yeah, it's not something bad. Actually, the meaning of hacker in the media is totally wrong. The meaning of hacker comes from MIT, from Massachusetts Institute of Technologies, and it means a very talented person who can change a problem or solve a problem very fast in a non-trivial way or traditional way, and like all 99% of other students could do that.
Right. Well, so this challenging yourself, you're talking about that with the antivirus. You did that when you took on the challenge of creating a self-driving car, or at least the technology for the self-driving car. Talk about that and the determination to do that on the cheap.
Yeah, so I started to do, when I was like 17, I was doing some online courses that was from Udacity in partnership with Stanford University, and online courses were about self-driving cars, and they presented a little bit of the theoretical backgrounds from how the Stanford self-driving car works and so on. And I got really interested in building the software and so on. But what they forgot to mention in their courses was that the Google self-driving car and Stanley were using a $75,000 3D LiDAR. And it was impossible to use that. So I understood how the 3D LiDAR works, and I actually built a $200 prototype. It was not that efficient and had the same resolution as the Velodyne 3D LiDAR, but it was quite competitive, and it could have been done could be used for something like a self-driving car for freeways or something like that, not with a lot of details. Right. And yeah, it was a great challenge. Now the technology is changing, and for example, when I proposed, I was just using neural networks because deep learning was not invented in 2013, or at least nobody was using it. And now the scientific world is changing from the simple neural network that I was using in 2013 to more deep learning frequent neural networks that are learning by themselves in order to be fully autonomous. And it's a great challenge for them to do that. The only thing is that the automotive market is very hard to penetrate, and because it's a tough business, and so I'm trying to be more focused on software that you can give, you can find customers, you can find something like that, and not only to rely on VCs and venture investors and something like that. And it's a different kind of business model. Also, just last year I graduated university, and for example, when I started my company, I was actually also a student, and it was very hard for me to do both. And I'm trying to maybe it's a mistake, maybe it will be proven not a mistake. I'm dreaming too big maybe, but we'll see. Maybe not this year, maybe in 5 years, who knows, but we'll see.
So in talking about the banking example, you talked about the distributed network, which made it much more safe in a way, or harder to hack. But I think a lot of people are concerned about driving technologies, car driving, truck driving, trains, etc. So how do they keep, how do systems keep hackers out of those types of systems?
Yeah, so centralized networks had been proved that, all the time there is a mistake over there. That's why, hacker revealed a lot of Romanians, they were able to hack NASA websites many times. So centralized systems are not very good. And I actually have a friend who hacked NASA like 7 years ago. And so centralized systems all the time, they have flows because they're not open source. They're like closed source code. And, automatically nobody can report a problem, and somebody maybe will report a problem by changing something. Right. And decentralized systems are more interesting because, all the computers, they verify the data. Not only accept the data, but also verify the data. So, for example, the blockchain purposes was to don't have trust in anybody. So all of the nodes, they don't have trust in anybody. You just validate all the transactions, you validate all of the math behind, because if the math from one computer gets 1 + 1 2 on all the nodes, they must be the same value, but all of the nodes, they verify that. So there is no trust in all of those decentralized systems. In centralized systems, when you pay the bank, you trust the bank that the bank will send that money to the receiver, not to somebody else or something like that. So it is a very different approach. And I believe that maybe not today, maybe not in 5 years, but in 50 years, the society will no longer be that centralized, will be more decentralized, because centralized introduce a lot of regulations, introduce a lot of barriers for researchers, for software developers, for startups, for companies, and it's not that great. I mean, it's a little bit good in many ways, but not in all of the domains, and it may be difficult for many businesses, and and the world will change, definitely will change, and I don't see judges in 50 years, I don't see cops in 50 years, 100 years.
Wow. Okay. So you're positing that decentralized systems of all kinds would be better. That's your vision.
Not necessarily decentralized, but I'm saying more AI, artificial intelligence, or something like that. Not in 10 years, but in 50 years, I can no longer see like also humans to to judge and to vote for us or something like that, because humans they have the uncertainty, right? While computers, they don't have that uncertainty. If you just restrict the computers to don't have that uncertainty, so automatically the world will change, and is changing a lot. Like I didn't have internet like 12 years ago. All my books were written, and I no longer read written books. Like I didn't have internet like 12 years ago, and like when I got my first computer, I was the first in my neighborhood who got the computer, and that was a funny story. I got the computer, and not because my parents bought it. They got it from a family friend who, they rented the money, and they borrowed the money, and he got the computer back because he couldn't pay it anymore. And the world is changing. Like 150 years ago, it was in the U.S. It was Pony Mail Express. There were no even TV. There was no even. There were not even cars 150 years ago or something like that, and everything was on horses. And now you can see how much is changing, thanks to the communication and the system that allows us to communicate very fast. And in the same way, I also believe that humans will be able to create machines that are smarter than us, because humans are just machines, made from carbon, not from electrons, from digital or something like that, but it is not necessary to be digital. because also in the past we had been able to, to create different kind of machines, not necessary to be based on silicon. For example, the first computer was in 19th century, I think, Babbage computer or something like that, and it was mechanical. So it is not necessary to be on silicon. Maybe it will be, I don't know, quantum computers. Now, all the crypto is quite afraid of quantum computers, but still it is quite a little bit far.
So let's switch gears and go to a non-computer-based part of your reality. In 2013, you won the Intel ISEF award.
Yeah.
And the video of that is kind of astonishing. You're so happy, you're breathless, and waving a flag. Tell us about that moment. Take us in that moment when you won.
Yeah, it was amazing for me because it was the last award from the entire award ceremony, and I couldn't believe it. And I think no other European was able to get that award in the last 20 years or something like that. It is the Intel International Science and Engineering Fair. I think it's the oldest and the biggest competition on the planet. It's for science and engineering. And Europeans, they don't have that kind of, at least in schools, European schools, they don't teach us, the students, to do projects, to do science projects, to do software. Because I went on a science fair project, but I did software. I did software, I did AI, artificial intelligence, and my research was actually software implementation. And it was breathtaking for me, winning that award, and I'm really grateful for Intel, not necessarily for, rewarding me with that award, but mostly because first time when I attended the Intel International Science Fair in 2010, I was the first time when I actually went outside of Romania, and I got in Silicon Valley, in San Jose. And first stop was actually in San Francisco because of the volcano problem in 2010. And I was, amazing when the first time when I got in the US, I got in Silicon Valley. And it was the first time when, I met so many people with different kind of cultures, with different kind of, nationalities. And that's one of the motivators that made me to work harder and harder every year, because I didn't win in the first year, I didn't win in the second year, not in the third one, the fourth one, and it was almost impossible to win that. And I was super happy and super excited, and I cannot believe even now that I was able to get that award.
It showed. The video is really cool. So what was the work that you had done to win that award?
So I implemented a software that uses artificial intelligence for recognizing traffic sites, traffic lanes, in order to detect the curbs, the sidewalks, in order to, I did a small prototype for a 3D LiDAR using photo detectors with 18,000 pixels as a resolution per second. I did some simulations in Rybnik Vulcha, so I installed all of the 3 cameras, four laptops inside the car, a driver of course, and I was collecting all the data, the 3D LiDAR on the roof of the car, and I was collecting the data, and I was able to simulate how the self-driving car will learn and how it was actually driving in some areas and so on. But the problem is that it's very hard to transform a research into a product sometimes. Right. And especially self-driving cars is super hard because the market is very, it's very difficult. It's very hard, and the only way you can, you need a lot of funds from VCs, and most of those kind of startups that they work in self-driving cars, they end up in exits for big companies and for corporations. And Romanians, they are not very good at that kind of stuff, that kind of business. And even I remember.
But you succeeded in actually using the technology. I mean, you put this on your dad's car and drove around for a while. Yeah,
I did some simulation. It was not 100% accuracy. But I wrote the software from scratch in just like 1.5 years, and
you say not 100% accuracy.
Yeah, it was not.
You didn't have an accident or anything.
No, I mean there were only simulations.
I see.
Because the problem is that when you write an AI software, you cannot actually rely on just learning by yourself or something like that. You need to do a lot of simulation, especially to see if it has been improved in the past and what is the current recognition that it was in the previous 2 months ago or something like that. Because you write new source code, you write, you improve your source code of the project, of the product, of the software, and you want to check the, the accuracy of the current accuracy that in the previous accuracy, something like that. You need to compare and to get some statistics from that, and other ways you cannot do. And when you have the higher, when it has then the high accuracy, and you believe that you can do that, you can start doing simulations, real simulation in special designated areas. But after that, you don't have regulated countries. For example, Romania, the country is not regulated for self-driving cars and so on. So tests will be very hard to be taken. But the easiest way you can test is on the freeways, and I was hoping to test on the freeways. Yeah, of course, with small, not high speeds, with just low speeds or something like that. But it's still a research project. You can just do only exits. I was talking with a few investors or something like that, but it's still very far away from making a product and even selling it. Because even if you have the perfect technology, then you still rely on partnerships. You still rely on distributors in order to ship your product. With car manufacturers, because the software also needs to control the steering wheel. Also you need a lot of interpretation of the situations and something like that. And it's still very difficult. The new research with deep learning, and this is just like almost 1.5 years, they are trying to use deep learning to learn by itself everything. So they just put the image from the camera to the deep learning neural network, and with a very small supercomputer or something like that, with a lot of video cards, GPUs, they want to train the neural network to copy the behavior of the driver. So the input is the image from the driver's seat, and the second input is actually the angle of the steering wheel. And so the AI is trying to mimic. It's trying to mimic the way the humans they drive on normal roads or something like that. They got some really good results, but still it cannot be it cannot work on any roads in urban areas or something like that. The first application will be definitely for freeways, because on freeways it's very simple. But you still need 3D lidars. I still believe you cannot do 100% only with cameras. They had also deep learning can be used to detect objects now better. And in 2013 was necessary to have a radar or a 3D lidar or sensors or something like that in order to detect objects, vehicles, humans, pedestrians. Now they started to do like software image detection using deep learning to detect from images different kind of objects like humans, pedestrians, bicycles, vehicles or something like that, traffic lights from images, but still it's not 100%.
So are you saying that with AI deep learning, it's actually mimicking and then writing code that would
No code. It's just like mimicking. So how it works, so the brain, it doesn't have code in the brain, and it's very interesting. It just have like kind of numbers, analogic numbers. It's not 0 and 1, it's from 0 to 1 or something like that. And some neurons, they just connect each other, they just simulate each other or something like that. It works with electricity, okay, analogic electricity. So the neural networks, the math behind neural networks is just to simulate the kind of very similar neural network just with pure math, with pure numbers. And so the neural network is trying to, generate a complex function in a huge space, it's pure math, and that is trying to mimic the data. So you have an input of the data, you have an output of the data, and it is just trying to understand what is the correlation between all of those data with all of those output. And it is just trying like trial and fail. It is just feeding the neural network with input data, is checking what it is making an output, what is the decision of the neural network, and it's trying to minimize that error. So at the beginning it's super random, it's super huge, and then it's trying to minimize the error between what was thinking the neural network and what were humans thinking. And by this way, the neural network will be able to generalize and to be used also in different kind of similar data. Because it's interesting, because if it was working 100%, then it only works in that kind of data.
Right.
And because it doesn't work 100%, it can also generalize different kind of inputs and different kind of images from dark and from different lights and something like that. And this is called the generalization of the neural network. And it's a new research. It is just like 1.5 years. In 2013, it didn't exist, something like that.
Right.
But it still needs time to be done. And yeah, I said in 50 years, I no longer see judges, cops, or something like that. I only see AI. But still, it's not that. And it is because we don't have enough computer power. Really, although we believe that the smartphone from our pocket is almost as good as it was the computers from NASA that they sent a person to the moon. Is very good. It's very similar in terms of comparison, but the operating system is very low and it's very slow and something like that. And neural networks, they need a lot of computation because images, it's a lot of data. Like we tend to say in an image there are a few objects, but for a computer there are pixels, but not only one pixel. There are 3 colors of that pixel. Right. Red, green, and blue, and there is a lot of data in that picture, and it is very, very hard for an algorithm to generate to create a function in a huge space, not with 3 dimensions, maybe in 10,000 dimensions, maybe 1 billion dimensions, that can mimic that function. And there is one theorem that can provide us it exists, that theorem, that function. It's called Kolmogorov theory. That shows us that mathematically there is a function that can simulate and mimic everything. But the problem is that it doesn't show us any kind of information how that function looks like. And the neural network is just trying to find a similar function that is very similar with the purpose. And so the problem is that the space is so large, and we need a lot of computation. And although the computers are very powerful, the human brain is more powerful than a computer actually, because the computer works sequential, step by step, while the brain is working in parallel. And so in many different applications, the human brain is working faster than computers and something like that. But who knows? Maybe quantum computer will be able to achieve that kind of stuff, but it's still very infancy, and it's very far away for that kind of computation. But pretty much we are limited by the computation power of the current technology of the computers.
Fascinating stuff. So do we have any questions from our online audience? Or anybody in our physical audience?
I'd like to throw one out there for you. Regarding the future and the development of AI, you mentioned maybe in 50 years, maybe we don't have cops, maybe we don't have judges. There's a certain side to that, but maybe we will also not have teachers. Maybe we also won't have doctors. We won't have other professions because AI has replaced those people. That's an element which I think society needs to think about. I'd like to get your thoughts on it, and I also want to throw out the more apocalyptic sort of scenario that people like Stephen Hawking and Elon Musk have talked about, where you have AI which continues to develop at an exponential rate and possibly becomes self-aware and surpasses human intelligence. So maybe you can sort of speak to both of those regarding both the social shifts that are already underway and going on right now, as well as the more extreme sort of scenario.
Yeah, so I'm not an expert in social stuff, but it's called the singularity point, when humans are able to create something like a machine or an intelligence or something like that can evolve itself automatically. By that time, we're going to have abundance. Because if we create something like a machinery that can replicate itself, will just generate abundance of everything, because it will be able to create any kind of other machinery.
That's right.
And so that's the holy grail of humans, to create an intelligent machine or device, or I don't know, anything that is more intelligent than us. Because if we are able to succeed in creating that, then automatically that intelligence will be able to create itself a better intelligence. And after that, you're going to apply the Gordon-Moore law, which states that there are some fields that can grow exponentially. If we are creating that, then the intelligence of humans that are then transferred to that machine or to that organism or something like that will grow exponentially. Right. So, And if you're very intelligent, then why you want to hurt humans or something like that? There is no purpose for that. If you can create machines and if you can explore the space by yourself, then why you should do something bad to humans? I mean, what's the purpose? Because they cannot use us as batteries. Only Matrix they used us as batteries, but otherwise, you know, we just live with them, like, you know.
Yeah. So would you say then you're a positivist for technology?
Definitely.
And maybe that's a generational thing, but you did live a time in your life without computers.
Yeah.
So talk about how you got so much into using computers, and even possibly why you think you're such a positivist about it.
Okay, so the first time I got a computer was like age of 3 or 4, and I got my first computer and I played Wolf 3D, and it was amazing to play, and I was not looking to go outside to play with the guys. I was just looking to stay in the house to play the video game, and it was super exciting because, you know, it was the machine that you was able to interact, and it was after you are able to learn how to work with the machine, then you can use the machine in different ways. And then I started to think how to create my own video game, and I started to write code in order to create my own video game, to create 3D movies, but I didn't like 3D modeling because it's very tough. And yeah, so it is mostly after you interact with the computers, with the machines, then you really, and if you understand how they work, and if you understand how you can make them to work for you, then it's super easy, and you really like to work with them. You can create software, you can, you know, create different kind of projects and different kind of applications. Not necessarily only software, you can also create hardware like the robots, the vision bot machines, and why I'm a very positive person, I truly believe that's the nature of humans, to create, you know, tools and to create, you know, things that help us. I mean, that's why we create a machine. That's why we, you know, the smartphone is super easy used because you can receive not only calls, but you can also receive messages, you can also emails. Yeah. You can surf the internet anyway in the country almost, thanks to the 3G and so on, and it became very useful. I mean, if you wouldn't use the mobile phone, then you had to wait 5 hours to meet one person, but you may not know where that person it is. So it is a useful thing, and only useful things will be adopted by humans. Because if they are not useful, they will not be adapted. For example, I can use the tablet to write code. It's very useless for me. I still use the mouse. But I don't believe the mouse will exist in 50 years. Maybe a different kind of interface will be created. Because the mouse wasn't created about 30 years ago, maybe. Maybe even a little bit later. Right. So until we get that kind of technology that is super useful, we will not converge in that technology. But if we find that technology that is super useful and people will just, you know, really use it for something useful, then we'll get adapted to that. Do you get my point?
I do. So the future is the Jetsons, not the Terminator, which I think
definitely.
we've talked about before,
And we create useful things, not bad things, because bad things will never be used. We only create useful things, and we only hope for the singularity. For example, it's very hard to transport humans to different galaxies and so on. It's easier to transport a nanotechnology that will just replicate after we'll go to the moon, and we'll just, you know, create the lunar base over there and just ship itself to other planets and something like that. But also it is very interesting that you know, we are thinking about this, but still we are limited by the physics. I mean, I was at NASA research, Moffett Research Park from California, and I was studying about space because everybody was enthusiastic about space. I'm not really enthusiastic about space. And what was interesting is that the speed used by rockets in 1970s was actually higher than the speed that they use at the moment in the rockets. So the speed for rockets didn't improve or exponentially improved or something like that. It actually get lower. And that's because physics, mechanics, cannot improve too much. At least at the moment, our knowledge is not to improve we are not able to improve the mechanics or something like that, and it's very hard. For example, the cars 100 years had almost the same speed with the cars right now. We found something else, the airplanes, that work better. So we are trying to, you know, to find better technologies that can help us in order to, you know, to do something useful for us.
Very good. Do we have any other questions?
Yeah, great.
Thank you for taking the time for being with us today. As you're aware that the success path is not paved and has a lot of challenging tasks. So for Alexandru, what's the most challenging tasks faced during your professional journey?
Wow, every day is a difficult task. I mean, I'm not born as a software developer. Nobody is born as a software developer. Every day, you find different problems you have to solve. So, even after switching from one technology to another one, it's still hard even for me. I have a lot of experience. I understand very well many things, but still cannot get everything 100%. I still need to learn. I still need to improve myself. And yeah, for example, I switched from software to hardware with the vision bot machines, then to electronics. We have also some electronic products, and now we switch to cryptocurrency. But it's simple, easy. It's not that complex because you have a lot of knowledge. As I mentioned before, I'm one of the, I truly believe in the Malcolm Gladwell concept with the 10,000 hours of experience to become a professional. So after you get 5,000 hours, then it gets easier and easier every day. Not zero, I mean, it's not piece of cake, but it's getting easier for you, and you just need to start. You need to start working and build your stuff, because if you don't build your stuff, nobody else is going to build for you. Actually, you may be going to be hired by somebody else to build their stuff, but that's something else.
So what is that thing, what is that discipline that you're dedicating your 10,000 hours to?
Computers. Anything that is related to computers. I mean, I truly believe computers are the future. I mean, at least 20 years will be the futures. And yeah, it's a very interesting and rewarding field, because being a computer geek is quite interesting. You go to Saudi Arabia and and it's interesting. And yeah, I'm trying to stick with technical side and not to get and not to abandon the computer science. Like a lot of people, they work like 10 years, 20 years in computer science, but after that they start abandoning. Like, they get a family, they get a job and something like that. They will no longer be able to have free time to build their stuff. And so, they start to lose the track, and they can no longer keep the, they can no longer keep the new technology, the new innovation that happens. For example, the internet is super amazing. Like, I didn't do any kind of internet stuff until 1 year ago. I was doing, like I told you, like software, desktop software, robots, electronics, hardware, not internet stuff, not web applications. And now I'm doing the web dollar, which is a blockchain in the web. It's something new. It's a new technology. And I found that this technology couldn't be done 1 year ago. Especially 3 years ago, couldn't be done web dollar. And I found that, I just I connected the dots. I saw the WebRTC protocol, I saw the WebAssembly, I saw the blockchain, and after that I also found there is also a light blockchain, and I just found, yeah, I can use it in the browser. And I started to work on that. We are not the first person, we are not the first team who saw that. We have seen a different team from Germany who are building something similar. Yeah, so it is not necessary to be the first, right? And because you don't need to copy others, right. But it is very important to do the research. So for example, in this technology we use something that was developed in the same time in two different places. Radix 3 and Patricia 3 were invented almost in the same year by two different people. And it is not necessary to be the first. You just need to work hard in order to build your stuff. It's not necessary to be the first who makes something or something like that, but you need to work hard to build your stuff, because otherwise, if you will not work, you will not be able to do that. So long live the workshop, essentially. Yeah, and to be a workaholic. Yeah. I mean, to be a workaholic is very good. It's excellent, because you see your dream happening. Because if you're not, you're gonna take you 10, 20 years, and maybe you're too late. It's also the momentum. It's very important. I learned this about the momentum. It's very important. Okay. We have another question here. Great. Yeah.
Just regarding the self-driving cars, I'm just curious about the data that is taken in order to learn the self-driving car. So you mentioned images, you mentioned 3D LiDAR. So what is the process from these images or these data to actually making the car self-driving? What is the process and preparation of these data?
Great. So I will explain how I used in my self-driving car solution for AI. So I built a few AI algorithms. It was not only one. Now they propose a solution with only one algorithm that learns everything. My solution was using multi-layered neural networks that were processing images to recognize traffic signs, but it was a little bit helped in order to recognize, for example, search only for the blue areas, for the blue signs, red areas for the red signs and something like that. And it was extracting windows from that image in order to find, and was trying to detect if in that picture, in that window, there is a traffic sign and what kind of traffic sign. And after that, it was able to detect there is a traffic sign, and it was classifying which exactly the traffic sign it is. Now the technology changed a little bit, but still with Windows. Then another neural networks was used for, I did a software to detect the traffic lanes. It was mostly a novel solution, was not an AI base, it was not improving itself. It was using the fact that there is a huge derivative in the image between the road and the traffic lane. There is a huge derivative in the image. The traffic lane is either white, yellow, or something like that, and the road is quite dark. So the solution was trying to understand with particle filter where are the traffic lanes. But it was still a probabilistic solution. It was not a pure AI, but it was a probabilistic solution. And I did also software with AI that was with Bayesian neural networks, that was trying to understand the decision, like with the traffic lights, with the traffic signs. So the inputs were different kind of states. What traffic sign detected, what traffic light it is, where are the lanes or something like that, and was trying to make a final decision of how to change the steering wheel, what will be the speed or something like that. Well, this one was not working perfectly. For example, for a Google self-driving car, they actually have hard-coded, they wrote that if the traffic light is here, is red, just stop. And this one was a little bit trying to improve itself over the time. And for traffic lights, it was definitely a neural network software that was processing the same with Windows. And the purpose is not only to detect the traffic light, but also to track it. Because if you are detecting now, you are also detecting the next frame, almost in the same position. So after you detect those traffic signs, traffic lanes, traffic lights, and something like that, you also track them in the pictures, because they must have very similar position and very similar states. You cannot switch from, I don't know, from this kind of lane to this one. Right? So it is more a probabilistic solution. That's the way I wrote my software. And for the 3D LiDAR, it was just only the Doppler effect. It was not learning by itself. It was able to detect in which direction the cars, the objects, because it was not able to detect if there were objects or cars. It was just detecting the objects in which direction and which speed was they were moving using the Doppler effect.
Very good. That answer your question?
Great. Excellent.
Yeah.
If you have other questions, I will be very happy to answer to them.
Yeah. Well, Alexandru, thank you for joining us today. Really appreciate it.
It was a pleasure.
Yeah. Alexandru will be here on the Facebook page for our online audience. He'll be giving a keynote tonight at 5:30. Make sure and check back and join us for that. Thank you and good afternoon.